Hi everyone, this is going to be a video walkthrough on Midterm 1 List, which is the 6th question on CS61B Spring 2021 Midterm 1. Okay, so my general plan for this video walkthrough is I'll walk through each question, I'll give you guys an introduction to what it's asking, I'll say pause the video, make sure you guys have tried it on your own, and then I'll walk through my intuition on how I approach the problem, and some of them I'll approach both iteratively and recursively just to give different feels of different solutions. Okay. Because I think for these questions, it's possible just to look up the solution and understand it. So for this video walkthrough, I'm really trying to emphasize building intuition for if you didn't get this problem the first time, what are some tips and tricks for you guys to apply to future problems, okay? So with all of this in mind, let's dive in. So for this question, we have this midterm 1 interface defined as follows, okay? So we have some interface here, and then what we're trying to do in part A is we want to add a default method to this interface, right? So let's first recall what is a default method and how does it work in an interface, right? So a default method in an interface means that every single class that implements Midterm 1 List will have access to this default method, right? They don't have to provide their own implementation, it's implemented for them with this default implementation, okay? So we're trying to create 3 default implementations of different methods in this question. And we're going to start off with creating this method called getEvens, which returns a new list with all the even indexed items. Okay. For example, suppose we have a Midterm 1 List called x with the items ape, banana, cow, and dog. Then x.getEvens will return a new Midterm 1 List with ape and cow, because those are the items at the even indices. Okay. So we need to fill in the code below, and it says here that the closing brace of the function must be at or before line 14. What does this mean? It's just capping how many lines of code we can add to this method. Okay, and we should say that x should not be changed in any way. So for this question, I'm just going to dive into the solution. So the idea here is we just want to iterate through all of the even indices in the given list and extract those elements using the get method, and then put those elements into a new Midterm 1 List. Okay. So how we should do that is we can create a new Midterm 1 List, and then we have to type it of t, and I was going to call it new list. And then how do we create Midterm 1 List? This is actually a very important point, is that we have to use this create list method, okay? The reason we can't instantiate a Midterm 1 List is because an interface doesn't have a constructor, right? So this create list is like a pseudo constructor for us to use. So after creating this list, what we want to do is iterate through all of the even indices, okay? So this is kind of cool. What I'm doing right here is that I'm iterating from 0 to 4, 6, 8, etc. using I plus equals 2. So we're not even looking at the odd indices. So we don't need an if check inside here, okay? So all we're going to do here is we want to add these elements to the new list, which we can do new list.add last, and we're going to get the ith element from the current list, okay? And then finally, we'll return the new list. So this is the solution for part A. It's not incredibly complicated, but there are multiple ways of approaching this. You could also do for int I is equal to 0, I is less than size, I plus plus, and then you need some sort of if check to make sure I is even inside. But this is a bit more concise. Nice. Let's move on to the next one. Part B. Suppose we add another default method, default public Midterm 1 List remove, that takes in a start and an end, and it removes all items in the list between indices start and end inclusive, and returns a list with all of the removed items. Okay. So then they're going to give us some example, but I actually don't really like their example that much. I'm going to create my own example. So suppose that we have this list, let's say 0, 1, 2, 3, 4, 5. And let's say that start is here, and let's say end is here. Okay, so I'm just creating a little example, and I like having a numbered list where the elements are the same as the indices. It just makes life easier. I don't like the strings, but anyways. So looking at this example, how I approach these questions is I see what am I given, what is the end result that we want, okay? The end result that we want here is we want this list to get mutated such that now it goes 0, 1, 5, because these elements are removed, okay? So that's the first thing that should happen. The second thing is we need to create a new list. So we need to create some sort of new list that contains 2, 3, and 4, okay? So these are the two byproducts of executing this method. And with this in mind, I'm going to explore this question using a for loop and then using recursion. But let's start off with the for loop because I find it that oftentimes people like the for loop way better. I honestly like recursion better, but we'll get to that one the second time around. Okay. So using a for loop, intuitively what makes sense in a for loop is that what if we start here? Like what if we start at the start and then we kind of like keep going one by one until we get to the end? Okay. So this idea is like really, really close to working. The only problem with that is we need to remove these elements, right? So if we're iterating through the list as we're removing elements, we're actually not gonna get all of the elements we need to remove because we'll skip people and it's just a big mess, okay? So instead, my idea is if we're given this list 0, 1, 2, 3, 4, 5, instead of iterating down the list, what we'll do is we will always stay pointing at start, okay? Each time we enter the for loop, what we're going to do is we're going to remove this element, we're going to add it to our new list, and then we're going to repeat. How many times do we want to repeat? Well, we need to repeat this. In this case, in my example, we repeated it 3 times, okay? So actually, you guys might not be able to see that. We repeated it 3 times. And where did this 3 times come from? Well, we know that start is 2, end is 4. So we can see with some calculations that 3 comes from end minus start plus 1. Okay? So bringing it all together, the intuition here is that we're going to execute a for loop 3 times. Or end minus start plus 1 times. Each time in the for loop, what we're going to do is we're going to remove the element currently at start. We're going to put that element at the end of the new list we're creating, right? And we're going to repeat this because we know the next time we enter the for loop, what's going to happen is that at this spot will now be the number 3, right? So in essence, as we're removing people from index start, the other elements later in the list will slide back into that start position, right? So with all of this preface, let's dive into the code, okay? So how this code is going to look is we should first figure out like how many times we should execute the for loop, okay? So let's create a variable int times, and I'm going to say it's going to be equal to end minus start plus 1. And we also need to create this Midterm1List. So I'm going to bring that down. Okay. Okay, so we have some Midterm1List, and we also need to return this. Okay, so now what we need to do is in this for loop, right, which we're executing times number of times, right, the actual value of I doesn't matter. We just need to make sure that this for loop actually gets executed this number of times, okay? Oh, it should be I plus equals 1. Okay, what we're trying to do here is we need to continually remove from the start index and put that element in the new list at the end, okay? So how that's going to look is we'll say new list dot add last get of start. Then what we're going to do is we're going to say, let's remove that element to prepare for the next iteration of the for loop. So we'll remove start, okay? So this is actually the final solution for this question. All we're really doing is we're creating this new list, right? And then we're executing this start number of times. Each time in the for loop, what we do is we add last get of start, right? And then we remove that element to prepare for the next time around, and then we return this new list. Okay. So I actually think the iterative solution here is a bit better, but I'm going to show you guys the recursive one just for fun. Nice. So I'm going to clear these drawings. So diving into the recursive one, let's see how we can solve this recursively. Let's say that we have the list. Let me get my pen mode of 1, 2, 3, 4, 5. And let's say that this is the start and this is the end. Okay. So our end goal that we want are two lists, right? We want eventually a list of 1, 5, and then 2, 3, 4, right? This is like how we want this method to work, right? So with this in mind, what I'm going to do is let's try to think about a potential recursive call here, okay? One idea I have for a recursive call is what if we call this function where end is 1 before the current end, okay? So in other words, let's say we do this. And let's use the recursive leap of faith, right? This is very 61A-esque, to see what would the new list that we get back be, right? So if we execute this, what we expect to get back are two lists, right? We expect this list to be returned, the one on the right, which will be 2, 3. And we expect the state of the current midterm 1 list to be 1, 4, 5, right? So all we really need to do to solve the question is take this missing 4 and add it to the end right here, right? Because that's what our original end goal was, to have one list, 1, 5, and another list, 2, 3, 4. And we see after executing the power of recursion, what we have is this state right here. So all we really need to do is take that number 4 and move it to the end. Okay? So how do we know like where in this list to take that 4 from? Well, recall, very similar to the last idea, is that 4, not coincidentally, but on purpose, happened to be at index start, right? And that's like the same idea that helped us in the iterative case, is that we keep removing from start. And that's going to happen here too, okay? So after executing the recursive call, we know that last element we need to remove is going to be at index start. So what we'll do is we'll get it from index start and remove it. And that's basically it. But we also need to deal with this base case. So let's try to explore that one as well. So we're going to have some sort of base case. I don't really know what it is yet, but my idea for the base case is to return a new list. Okay. Then what we're going to do is we will call our function recursively. Okay, so we'll say Midterm1List new list is going to be equal to remove of start and n minus 1, right? Because we're not trying to remove the number 4 in this example. We only want to remove 2 and 3. Okay, so after executing this recursive call, let's note that we expect our current state to be such that we have a list 2, 3 that's returned, right? 2, 3 is going to be this new list right here. And the state of the current list is going to be 1, 4, 5. So all we need to do is take the element at index start and add it to the end of the new list, right? So let's do that. So we can do new list dot add last. And what we're going to add last, we're going to add get of start. Okay. So the next thing that we need to do is we need to actually remove that element at index start. And then finally, we need to return new list. Okay. So this is the solution for the recursive case, but we just need the base case here. So when do we want to return a new list, right? When is the only case that we don't actually add any elements to the list that's given? So let's think about it. What happens if start is equal to end? Should that be our base case? Let's see. let's say start and end, both point to 2. Okay, what'll happen in this case is that we would actually return a list containing one element 2. So that can be our if case. Our if case has to be 1 after this, when end is going to be less than start. So if end is less than start, it means that it's the iteration after the one that we're at right now, right? So yeah, this is the recursive solution. I hope you guys enjoyed it, and let's finally dive in to the last question, reverse. Okay, so let's first understand what the question is asking, and then we can dive into the problem. Lastly, suppose we add another default method, default public void reverse. This method reverses the list and returns nothing, right? In other words, it's a void method. For example, if we have a midterm1 list called x, which has all of these elements, after reversing it, we expect this list to be reversed. Okay, so we can use the keyword new, and we can call create list. Okay, so there's a couple ways we can approach this. I'm going to show you guys two solutions. The first is a very clean iterative solution, and the second is a very clean recursive solution. Okay, so this one, I think it's kind of hard to stumble upon these solutions. I think the recursive one is actually more intuitive and easier to stumble upon. This iterative solution is very big brain, even for me, but I'll give you guys the explanation of what's really happening, because I think it's a really cool solution. So what we're going to do here is, suppose we have some list. I'm going to use a different color. Let's use the white section. Actually, I'm keeping this. Say that we have some list that goes 1, 2, 3, 4, 5. Okay, and we want to reverse this. Right? It's a very classical programming problem. One cool idea, which this iterative solution is going to leverage, is let's start right here. Okay, we're going to start a for loop here, and we're going to go backwards. Okay, so what our for loop is going to do at each iteration, it's going to take the current element that it's pointing at, and it's going to add it to the end. Okay, then it's going to move 1 down. Okay, then it'll move to point at 3. So let's just kind of like walk through a few steps of what's happening here, and you guys will see that this logic indeed works. So let's look at a small example of 1, 2, 3, 4. We're going to start at the second to last element, and after the first iteration, we're going to remove 3 and add it to the end. As such, our list will now look like so. Then what we're going to do is go to the next one. We're going to remove it and add it to the end. And then we get 1, 4, 3, 2. And then finally, we're here, we remove it and add it to the front, and we get 4, 3, 2, 1. I think this example is hopefully illuminating enough, so let's just dive into the code. I'm going to erase this. So into the code, what we want to do is we want to iterate for int I is equal to size minus 2, right? The second to last element. I is going to be greater than or equal to 0. I minus minus. Okay, so at each iteration, what we're going to do is we're going to take the element at I, add it to the end, right, and remove it. Okay, so how that's going to look is, let's first extract the element at index I. So we'll say t item is equal to get of I. Then the next thing that we're going to do is remove this element at index I, and then we'll add it to the end. The item. Okay, and this is actually it for the reverse iterative solution. I hope you guys think this is kind of cool. I think it's really cool. So let's dive into the recursive one now. Okay, I think this one is actually like more possible to stumble upon. There are many other solutions to this question. I just chose 2 of like the coolest ones. So when we're looking at the recursive solution, suppose we have some list 1, 2, 3, 4. Okay, and let's just decide to call our function recursively on 2, 3, 4, right? What we expect to happen is that our MT1 list will get changed to 4, 3, 2, right? Then all we need to do is take that element we removed and add it to the end. Okay, so that's it. That's actually the entire logic of the recursive solution. We just have to deal with the base case. And to deal with the base case, I'm just going to like recursively iterate down this process, and then we'll see what will happen. So if we have 1, 2, 3, 4, what should happen is that we say, okay, 2, 3, 4, let's call our function recursively. So the list will now be 2, 3, 4. But this is like a bit confusing to do because we're not actually having a parameter to the reverse method, right? So how can we call a function recursively on this sublist here? So what we're going to do is we're going to remove 1, store it in a variable, call our function recursively on 2, 3, 4. Okay? So what's going to happen there is we will now have 2, 3, 4 in the list. Then we'll remove 2, store it in a variable, call a function reverse on 3, 4. We'll remove 3, store it in a variable, call a function recursively on 4. Then, now that we have a one-element list, we know the function is, or the list is indeed reversed. So what we can do is go back up the recursive tree now, and then what we'll do is we'll take 3, which we stored in a variable in this function call, add it to the end. We'll take 2, which was stored in a function call, add it to the end. So now it lists 4, 3, 2, right? And then we take the 4, 3, 2, and then we add 1 to the end. So we can kind of see that this process of using recursion actually works. So let's just quickly implement the code. So if the size of the list is greater or equal to 1, that means we actually have to do some work, right? Otherwise, there's no work that needs to be done. So what we're going to do is we will get the item at the start. We will call, actually, we should also remove this item. Then we'll call our function recursively, and then we just need to add this item to the end. So yes, this is all for the recursive solution. I know I did that really quickly, so let me just walk through it once more, just to solidify it in everyone's mind, okay? So what's happening here is we can break it down. We only want to do work in this function call if the size is greater than 1, right? This is another way, this might be a bit more familiar for you guys. Like equivalently, what I could do is I can say like if the size less than or equal to 1, return. This is like the same solution. I just wanted to save a line of code. Okay. So both solutions are the same. Okay. So what next thing that's happening here is we get the element in the beginning, right? We remove it from the beginning. So now the state of our list, in the case of 1, 2, 3, 4, becomes 2, 3, 4, and this value right here is going to be item, right? The next thing that we'll do is we'll call our function recursively. Taking the recursive leap of faith, let's assume that this gives us 4, 3, 2 back. The last thing that we do is add last of this item, which adds 1 to the end, right? So yes, that is all for reverse. I hope you guys enjoyed this video walkthrough, and good luck studying for your upcoming midterm. Let me stop this.